Well, we're going to look at what we've learned from the Mount St. Helens eruptions. I had the privilege of being out there for 5 days with Keith Swenson and Steve Austin, and along with about 150 other people in August of this past fall. And so it was a very unique opportunity to look at Mount St. Helens in a special way. I put out a newsletter on science and nutrition and gardening 6 times a year. If you want that, email me. Also, if you want a copy of these slides, email me. You see my email up on the main page here. I'd just like to start off with, I think each person has to have a final authority that they go to determine whether something is accurate or not. And I go with God. If God said it, then I believe it. Many people have what man imagined how it might be as their final source, and that's their choice. But something I'd like everybody to keep in mind is that information only comes from a mind. And where did that original DNA information come from? Had to come from a fantastic mind. And that's, biology can't make information, etc. It's all got to come from a mind. Information comes from a mind. So let's get looking at that. That was just a little bit of my philosophy, so to speak. When we try to interpret the past, there are often several theories that people come up with of what really happened. And sometimes those things fit with reality and sometimes they don't. And with Mount St. Helens, we actually saw significant amounts of geology happening in real time. And it gave us an opportunity to study and learn and to be able to better interpret. The rock record is always accurate. It was laid down, it wasn't messed with, but our interpretations always haven't been accurate in the past. And I think because of Mount St. Helens, we can be more accurate in the future. You can download a 142-page U.S. Geological Society professional paper on Mount St. Helens. You might find that interesting. The book Footprints in the Ash by Dr. John Morris and Dr. Stephen Austin also can be very interesting. Just wondering how many of you get the Acts and Facts magazine? Well, probably a fourth of you only do. It's a free subscription. I'd highly recommend it. It's some of the latest research, not just only what the Institute for Creation Research does, but with looking at all kinds of research. There's archives on there for decades back, and it's a free 24-page magazine. Sign up for it. I think you'll find it very interesting and worthwhile. I gave you a handout with some of the key points that happened on May 18th, and we'll go through those. These can be they're in no particular order, kind of how they've happened, but if you look on the internet, you'll find other people have these in, especially the last 3 in different order, and that's fine. And then there's some events that continue on after the May 18th, 1980 eruption of Mount St. Helens, and we'll be talking about some of those also. In October, Dave Nutting talked about Yellowstone, and we see Yellowstone down here in the lower left in this big yellow balloon. This is a volcanic explosivity index comparison between some different volcanoes that happened. And so this is a fairly big event making Yellowstone, whereas if we look up here, we're going to see Mount St. Helens, and it's really a small event. And keeping that in mind, that this is just a small event, and yet it had significant impact on the landscape, totally changed the landscape of that area, and totally changed our way of thinking on some things. So even though it's a really small one, we learned a lot from it. Here's what Mount St. Helens looked like prior to the eruption, located down in the southwest corner of Washington State, probably about 60 miles, I guess, from Portland, Oregon. When it erupted, about 3/4 of the material went off to the west, to the other side of this ridge. This ridge is called Harry's Ridge. And off to Spirit Lake, about 1/4 only went. And we'll learn a lot more about that as it goes on here. They say that Mount St. Helens was formed during the receding global flood, and that's based on the Pleistocene era. Here's some of the significant things that did happen at Mount St. Helens. Obviously, the mountain no longer looks like that neat cone. There was 3 canyons formed at different times. There's hundreds of layers laid down just in short amount of time. It doesn't take centuries for layers to be laid down. Several river systems were formed in a matter of hours. 2 new lakes were formed. And with about 1 million logs floating on Spirit Lake, about 10% of those floated upright and eventually sunk and looked like planted trees down below. And we also have some new models for how coal is formed and how an area biologically recovers. So those are some of the key things that we've learned from Mount St. Helens. If we look at a map of the area, we see Mount St. Helens down in the lower part of this. We've got Spirit Lake up here northeast of Mount St. Helens. This is the Johnson Ridge Observatory, where the public generally goes, and then they can actually view right into the kind of the mouth of this horseshoe-shaped remains of Mount St. Helens. We also have the North Fork of the Toutle River running east-west. It goes that way. A couple other things we're going to be talking about will be Harry's Ridge. Well, I mentioned it a little bit earlier. And the Little Grand Canyon is down over in this area. This area right here is about 6 miles from here. So you can get an idea of the scale of this map. That's about 6 miles. Okay, item 1 on the list is the earthquake. Well, in the fall of 1979, October, there started to be a few little ash and steam going up once in a while. But on March 16th, 1980, that's when things really started to happen. And between then and May 17th, that's about a 2-month period of time, there were over 3,000 earthquakes in that area, greater than 2.5 on the Richter scale. And they say that 2.5 on the Richter scale, an earthquake of that magnitude, a person can feel. March 27th, a steam explosion and a crater forms. This is a crater that's on May 17th, 1980. So we're still a day away from explosion, but that's what the mountaintop looked like just before the day before it exploded. And another thing, this is May 1st, but there was a bulge forming on the north part of the mountain, mile high, half-mile wide, and 450 feet thick. That's a huge bulge of magma that's forming down there. We'll look at that in a little more detail a little later here. So that earthquake that starts everything off is a 5.1 at 8:32 in the morning of May 18th, 1980. And what happens is there's an earthquake. That earthquake is right below, they figure, the northern side of the mountain, and it breaks loose the bottom part of that bulge in the mountain. And we get this first stage of the landslide. That first stage is about 3,300 feet down already from where it was. This is a picture they figure was taken about 26 seconds after the eruption starts, or after any of the major events, after the earthquake, I should say. It was taken by Gary Rosenquist, and we're going to learn a little bit more about him a little bit later here. But that first stage we see is already going down over 3,000 feet already. The second stage is about 300 feet down from where it was. And these are big chunks, and they're flowing like wet cement. And if you don't know what wet cement flows like, please look on the internet at wet cement and you'll see how it flows. And what happens here is that first stage goes out at a fairly good pace and out quite a ways. But now the second stage can scoot right along on top of that wet cement. Well, it's not wet cement, but the wet material, and go at a much faster pace. And later we're going to have a couple more explosions, and that third stage is going to be able to come off the top. And that third stage is about 1,300 feet of the top of the mountain. And that's going to travel at about 150 miles an hour. So that's going to be hustling right along. And it's a huge amount of soil. 1,300 feet of the top of that mountain is coming off. And it's going to continue on. 6 miles downstream, I pointed out where the Little Grand Canyon was. At that level, it's still 150 feet deep. It's over 600 feet deep here at the base of the mountain, 150 feet deep there. And by the time it goes out about 14 miles, it kind of peters out. And that's the third stage. But that's a long way down, 14 miles of dropping material behind. Here's kind of the flow again. Harry's Ridge, we saw right here, kind of being a divider for about a fourth of it going over to Spirit Lake and 3/4 of it going kind of west-northwest down the North Fork of the Toutle River, and kind of held in place, some of it by Johnson Ridge. Some of the blast in the air and stuff, though, goes many miles out. This landslide, they now call hummocks because it's big chunks of the mountain that are filling in the Toutle River. And here we're standing on a hummock probably 50 feet above the surrounding material. And at this point, it's over 150 feet deep yet. We're not quite at the Little Grand Canyon here. Here we're getting closer to Little Grand Canyon. You kind of see it in the far background there. But yeah, and this is kind of like parts of the Little Grand Canyon too, but these are all hummocks on the left and on the right. You can kind of see the size. That's a hummock. These are all hummocks. There's a hummock here. Here's a hummock here. So they're quite large chunks of soil. And so if somebody asked you, hey, how could I stand on the top of old Mount St. Helens? Well, just go up on one of those hummocks, because at one time they were part of the top of Mount St. Helen. Kids like things like that. So when you're talking to the kids about science and stuff, if you can come up with a few interesting little things like that, they like that. Here's what the Toutle River looked like after that landslide. It did not run water. And again, we're looking at 100, 150 feet deep of these hummocks, of these chunks of Mount St. Helens filling in that river. It's going to be 22 months later that there's going to be a mudslide that will recreate, come over the top of this and create a river system again. This is what that river system looked like. We're still above the Little Grand Canyon here, but you can, this is 1985, but you can see the river system here that formed. And here are hummocks again, 50, 75 feet high. So you get a kind of an idea, or 100 feet for the scale here. I should go back. This hummock area right down in here, we're going to look at on the next slide, and you're going to see it's all turned green, all of this area. And that's this area right down in here. all turn green with the trees and stuff. And here we see hummocks and erode, things aren't growing much on some of these hummocks because there's still a fair amount of erosion taking place off of them. So we've got that landslide material, and it's about 150 feet deep yet here. So the landslide below this line is about 150 feet deep. And this is in the Little Grand Canyon. And we'll look more at that as we go along here. So this is several of Gary Rosenquist's pictures put together so we can kind of see the event in action. He took these from 11 miles away, and yet we've got some pretty good detail. You can see that first stage of the landslide, the second stage up there, and just at the end of this, that last picture, you're going to see the eruption just starting up here. When we got that much off, now some of that steam pressure and stuff can come through. So got that first stage, second stage, and then here's the next sequence of pictures. What's going to happen just over about the next 15 seconds. This is a rapid event, and there's different opinions on lots of things on Mount St. Helens. For instance, how fast is this blast going? 200, 300, 650 miles per hour. You'll see all of those numbers on internet. I lean towards that 200 to 300 mile per hour, but I've got no real reason other than who did the work on it that I trust. The steam temperature, anywhere from 600 degrees to 1700 degrees. And I lean towards the higher temperature on this one. We've got molten rock and stuff going on here. So I think that's pretty neat that we got those pictures to be able to see that kind of how this is happening. You can see that landslide is continuing on down, and pretty quick, this lateral blast is going to far surpass it in speed. We're going to have still 2 more explosions after this, and that's when the whole top of the mountain comes down as that third stage of the landslide. And so why did it come out the side? Well, actually, in the 1840s, 1842 to 57, there were a lot of small eruptions and stuff, and a magma plug was formed on top. And now, when the magma was coming up, it was not able to move that plug off. And so it couldn't erupt like a regular traditional erupting volcano on top. Instead, the magma pushed out the side. We saw that big bulge, and then it's going to blast off towards the north. And all of this is going to create a significant change in how things look around there, anywhere from 150 to 250 square miles, they say. Excuse me. Here you can see clear, larger picture of the blast. That's 833.3.7 seconds in the morning. And here's 15 seconds later. This thing is really growing fast. Gary Rosenquist, the man who took these pictures, was 11 miles away up at Bear Meadows. Mount St. Helens is down here. He was shooting across up in Bear Meadows here. And the only thing that saved him was this ridge that's about a mile closer to Mount St. Helens than what he was. And the blast came off and went up over the top of him. And that's what saved his life, is that he had a ridge deflecting that blast. Okay, the fourth major part of this eruption is the airfall tempera. And that's superheated ash, rocks, and gas is tempera. And here, 2 months later, the place looks like, well, a desert or the moon or Mars or who knows what. Not anything there. The superheated gas and stuff really cooked everything. It also put out a shock wave. People did not hear this in the area. 300 miles away, all the way up to 300 miles away, they heard it. But people right in the local area never heard a sound of the explosion. It was too great and too close. But this shockwave leveled trees up to 3 or 12 miles away and scalded trees 17 to 19 miles away. And so we got 600 to 1700 degree temperatures here, scooting along at fantastic 200, 300, 400, 500, 600 mile an hour. And also the ash shoots right up in the atmosphere, and within 2 minutes of the initial explosion, it's over 14 miles, 14.4 miles high up in the sky. And that's the highest it's ever going to get. It'll continue spewing out lots of ash for the next 9 hours, but it's never going to be up that high again. However, it'll cover several states and stuff. Here's the shock wave mowing down the trees, just different views of it. And again, 150 to up to 250 square miles is the estimates different people have. And it's all done within a maximum of about 6 minutes. All of these trees are leveled. And again, a warm, hot blast of 500 plus degrees, depending upon how close you were to the mountain. This elderly couple, were 17 miles away from the mountain, driving on a forest road. One of them shooting pictures with the camera, and the other one driving away from the explosion. And the only thing, again, that saved these people, you can see the scorching and the dead trees and stuff here. The only thing that saved these, again, was a ridge. Well, in this case, 2 ridges that the blast was raised up over them. Altogether, 57 people died in Mount St. Helens. 2 of them were photographers, and the other 55 were other people, some of them scientists, and some of them just people out doing things. 20 of their bodies have not been found. And I would guess by now, with the temperatures and the amount of sedimentation and stuff they're under, that they are now fossilized. This is 21 years after Mount St. Helens. I was out there, I was speaking at a conference in Vancouver, so I ran on down to Mount St. Helens to see what the whole thing looked like. Anyhow, look at the size of that log. These are the kinds of logs that were toppled by that blast. This is about 5.5 foot in diameter. Anything up to about 6 foot was common, and up to 200 foot long. This was an old dead tree. That's why they didn't log it out of there. A lot of the trees, for about 2 years, they hauled basically every day of the year, hauled lots and lots of logs out of that area to save them. The volcanic ash isn't really an ash like burnt wood, but it's exploded rock that's been exploded by steam, and it looks a lot like an ash. Behind us would be Mount St. Helens. We're looking out over the Pumice Plane. We can see Harry's Ridge ahead of us. We can see Spirit Lake off to our right here. This pumice comes out and goes over a large area, but this Pumice Plane is just plain all pumice, and it's very light material. It actually floats. Here you can see some pumice. I can't show you how light it is, but it actually floats in water and stuff. And here's one of the guys on our trip, one of the medics, and this is 6 miles from Mount St. Helens. And there's these big 1.5 foot diameter chunks of pumice there. Some of the guys were showing off holding up 2 at once and stuff like that. But Julie Von Vett mentioned that this is the kind of shape you got to be in order to do one of these hikes. So, okay, the giant water wave. Well, that landslide is going to fill in 197 feet of Spirit Lake. Spirit Lake's bottom is going to rise by 197 feet. It's going to push all of the water out of the lake, push it up the hillside 860 feet, and then that water is going to come rushing back, bringing in approximately 1 million logs from 6 different species of trees. And those logs totally cover the lake. And as I said, the ash continues for 9 hours. It covers all of these logs, and the place looks like the lake is gone. And in fact, the aerial reports by pilots was Spirit Lake is gone. It's just the outline is left. They didn't realize it was just covered with logs, and then the logs covered with ash. A few days later, you can see a picture here. You can see some of the opening of the water and stuff. Look at how desolate that is. This ridge off here is the one that saved Gary Rosenquist. And Bear Meadows is, this ridge is 10 miles away. Well, Mount Rainier is 50 miles away. But that ridge is what the blast went over, and he was about level with the ridge over there. And here's Harry's Ridge. There's a series of these. That's a whole nother study of when that happens in the latter part of the flood. This is August 2021. Still a lot of logs floating on Spirit Lake, but there's only 2 of the 6 species of trees, the Douglas fir and I forget which other one, are the 2 that are still floating. All the rest have sunk. Still, again, like I say, a lot, and these 2, 3, 4, 5, 6 foot logs, and all of the branches and the bark and the root systems off. It's sunk down to the bottom of the lake. It's about 3 foot deep. And now if we had some kind of a rapid burial or any kind of a burial system that would put 100 or 200 more feet of 50 foot on top, I don't know exactly how much, just so it'd be hot and some pressure, we might get coal rapidly formed. Here you can see floating upright logs on Spirit Lake. And by 1985, there were over 19,000 of them that were planted upright, looking like planted trees down on the bottom of the lake. And we often had heard about Specimen Ridge in Yellowstone Park having 27 different times where there was flooding and stuff, and trees flooded and covered over. Reality now, looking at those closer, it's the same kind of thing as Spirit Lake, and it's all after probably just 1 or 2, probably the one major eruption, and then a lake, and it just over a period of time, 27 different layers, just like there's different layers coming here at Spirit Lake. In 1979, Dr. Steve Austin was defending his dissertation on how coal is formed. And he was going up against the traditional thought that it was from peat. And he said, no, it's material brought in. Well, within another year, Mount St. Helens happened, and we see it's trees and stuff brought in. It's not peat that is forming coal. And so Dr. Austin's PhD is probably one of the first ones that has it right. Here we see the coal stream seams that are in the eastern part of the United States. We'll talk about eastern and western. You can see the size of cars here on the picture on the left. And those coal seams are 10, 12 feet, 13 feet high, maybe. Most coal seams in the eastern United States are not very thick. where there'll be 50 to 200 feet in the western United States, and we'll cover that later on why. But volcanic ash and clay are present in these, and that just further shows that not only were there trees brought in, but there was volcanic events and tremendous global flood that created all of this. Here you can see the size of some of those trees on Spirit Lake. Again, 3, 4, 5, 6 foot diameter, a couple 100 feet long. This is part of our group. We were divided up into 4 different groups, and this was part of our group. So each day there was a different group down at different places. Okay, the 6th part of the eruption are mud flows, lahars. Here we see a bridge that was carried about a mile or a fourth of a mile downstream by the mudslide, the mud flow, not a mudslide, a mud flow. And again, like flowing cement, and it can carry about 4 times its weight, can float on top of it. And so these big rocks just floated along on top of that. But moving at 90 miles an hour, there's a lot of energy and power there. It's about 91 degrees Fahrenheit temperature, and it can crush a bridge. It can do lots of damage. Here we see that it was like 30 to 37 feet high, 30 to 37 feet deep as it was flowing down the river. You can see this person here in front here. Even, let's say that's about a 5'10", 6 foot person, something like that. You can see we got 30 to 37 feet here of mud. And this is how deep the mud was when it come floating through there. And again, big things from off the mountain are carried down. That mud flow went down into Pine Creek. This is a rock that was carried along in that mud flow at a 33-foot level above the creek of mud, 33 foot deep. And it's a 37-ton boulder. And it was at one time up on the mountain, but now it's been carried down by the mud flow. You often hear of grooves created in rocks by glaciers. Well, that's true, but grooves are created in rocks by mud flows and other action, as we learned at Mount St. Helens here. Those are pretty obvious grooves in the rock, with one rock rubbing against the other in the mud flow. Here we see the mud flow and the devastation in a logging camp. Those are pretty big trucks and semis and stuff that are all just toppled like toys. Here's the Toutle River full of logs and stuff. And that bridge was high enough so it wasn't wiped out. Many of the bridges and stuff were totally wiped out, because if it was like 30 feet above the river of mud coming down, any bridge that didn't have at least a 30-foot clearance was wiped out by that power. Some things were flung in the air also. I actually got to see this truck 21 years after the event. Here's the 7th aspect of the explosion of the eruption. Pyroclastic flows, hot ash flows. It's this tempera that we're talking about mixed with really hot gas, that's 600 to 1700 temperature. It hugs along the ground. It travels along the ground very rapidly. There's some nice videos of these kinds of events in other parts of the world. You can't outrun these things. They're moving along too fast. In fact, the man taking this picture died, and people ask, well, how did the film get preserved? Well, he saw it coming, threw it in his camera in the backpack and laid on top of it, and that was the end of him. But they found him, his backpack, his camera. Another one was found in a car later. So thank you guys for taking the pictures. Here's a real small pyroclastic flow on August 7th, 1980, a couple of months after the main event, just come hustling out. Again, you cannot outrun these things, and they'll kill you instantly. So we've got the landslide below the line. Now we're going to have these pyroclastic flows. In fact, there's 17 of them happen over about a 3-hour period on June 12th, 1980. And we can see the landslide and the pyroclastic flow all happened within the same hours, day, whereas this pyroclastic flow erodes for a couple of years, well, 22 months before above this will be another mud flow on March 19th of 1982, March 12th, I forget which date. Anyhow, March of 1982, 22 months later. And there's a lot of erosion has taken place in between. That's no longer a straight line compared to this one. That's a nice learning picture in that regard. The pyroclastic flows from those 17 little eruptions over 3 hours put down hundreds of layers of material. You can see the layers there, 25 foot deep. And the further back you go, between the landslide, the pyroclastic flow, and the mud flow, we've got about 600 foot of strata by Mount St. Helens, all the way down about 175 feet, 190 feet at the Little Grand Canyon, down to nothing, probably 14 miles downstream. But all of these layers formed by a flow process, flow of water, flow of hot air, flow makes layers. And we've got hundreds of layers from less than a millimeter thick to over a meter thick from those 17 pyroclastic flows. Here you can compare a hand to that little segment there, and I counted 45 layers, thin layers in that little segment right there. And they say there's only 100, some, secular people sometimes on the internet say there's only 100 layers. Well, I got 45 layers just in that little bit, and there's hundreds of layers there, all laid down in about 3 hours. Had we not seen that happen, how many hundreds or thousands of years would people have said it took for those to lay down? Now, they didn't take, again, about a 3-hour span for 25 foot worth of all these different layers. The South Toutle River from Lewitt Canyon, that's another canyon that formed at the base of the mouth of Mount St. Helens. And once you see the picture that's coming up, I just say there's a lot of things to study in that. It's a phenomenal area, and I haven't seen a lot of research being done on that. I really wonder about this segment right in here, if there wasn't a steam explosion below that would have dropped this, because this would have all been laid down straight. And we've got something definitely happened. I'd love to know who studied that. I've not seen who studied that, but this is one of the canyons that formed right by the mouth of Mount St. Helens there. This is the South Toutle River, the South Fork. So these steam explosions, like I just mentioned before, this is in the North Fork of the Toutle River. This is a picture on the 5th day after the eruption. Ice and water got trapped in the avalanche material, and then the hot pumice that came out, the airfall tephra, was 575, 600 degrees in this area, and it melts the ice and water that's trapped there, and after a time expands enough that it creates actual explosions. And here's the largest explosion, was about 1,000 feet wide by 2,300 feet long and 125 feet deep. That's a big explosion from water and ice turning to steam by the heat and then exploding up. You can see just here's another example of a little one right in the back here and stuff. But they don't know for sure when this was formed. This is 5 days, a picture taken 5 days after the eruption. And we've got huge pit, and look at all of the badlands that are already formed. And I think a lot of that has to do with material exploding up and then come washing down and creating those badlands, probably all in just a very short period of time. That's just my thought. I don't know for sure how the badlands were formed, but we know they were formed very rapidly. And by the 5th day, at some time during those 5 days, this pit exploded and those badlands formed. So we only got 5-day interval there for all of this to happen. In 1992, 6 years after the forming of the main part of this 1986 dome, Dr. Steve Austin went up and collected 69 samples and had those aged with potassium argon aging. And depending upon whether he used a full rock or just certain minerals from within the rock, he got different ages of anywhere from 350,000 to 2.8 million years. And we know it to be 6 years old. So there's something going on there. The radiometric dating hasn't been very high on my radar screen of being accurate. Here's the dome in 2019. You can see it here, and I'm not sure when that picture was taken. This is 2019. However, that Lewitt Canyon I just showed you is right here. It's over 100 foot deep and quite long, and a beautiful waterfall at the end of it there. But here you can see the dome in 2019. It's filled in a lot of this area. You can see a lot of the telesloping happening and stuff. Lots of erosion still happening there. And now we're 39 years after, and at a distance, it still doesn't look all that green. And you can see the different erosion and stuff. And up at this end, where the mud flow and stuff comes out thick and wide, we get some side canyon forming and stuff on the main rivers. Here's another picture of that Lewitt Canyon. And there you can see the waterfall and stuff. But that cut through hard basalt bedrock. It wasn't anything that was fresh and easy. It was old bedrock that it cut down through, and you can see that bedrock right here and stuff to form this canyon. So that mud flow had a lot of power to cut through hard bedrock as well as form the river and stuff. Here's what the mud flow looked like. Where we've got the wider flows here, that's where we get side canyons in the river. Where we only have a narrow flow down further here, where we only get a river. Basically, this all results from 2 explosions that melt the glaciers and the snow up there. And this mud flow comes rushing down, creates that Lewitt Canyon, and goes over all of this hummock area that's in the North Fork of the Toutle River, 100 foot deep. And the further down it goes, the less deep it is. When we get down 15 miles or so, we're down to 37 feet deep only. But this creates the flow in the Toutle River again. We look at the side canyons, the Mount St. Helens would be about right here coming out. And we got the flow going here. Here's Harry's Ridge and the lake off over here and here. But at the upper part here, you're going to see side branching and stuff on the canyon because we got wide mud flow there. Where we got narrow mud flow, like if it would just be one break, say there was just a break of a dam here of a lake, you just got a straight stream. You don't have the side flows near as much as up in this area here. And I think that's an important thing we learned from Mount St. Helens. So we got the little Grand Canyon, 140 feet deep, 14 miles long, and 9 hours or less time that it was all formed in. that big mud flow coming down March 1982. So the bottom part here, the landslide, the pyroclastic flows, all deposited on May 18th, 1980. Lots of material. And the mud flow, March 19th, 1982, is above that. So again, we had 22 months for some erosion to take place. We don't have a straight line like we have here. And my lines aren't perfect, but the intent is to show the difference. Here you can see the eroded, uneven mud line between the pyroclastic flow and the mud flow, and the layers very level and nothing in between for like the pyroclastic flow that was all done in one day. So there is a difference there. Even in a couple of years, you see erosional differences. And again, we've got a flow going on. We've got a mud flow, and so we're going to have layering. You can see the layering in the mud flow too. Here's a mud flow over a hummock. And again, we're talking a 50-foot hummock and 10, 12, 15 feet of mud flow over the top of that. Biological recovery. Did somebody, okay. May 18th, 1980, the ground is snow covered. Animals and insects are hibernating and they're protected below. Here's December 1980, and there's not much for biology out there at that point. There's a couple of islands we see in the red circle here on Spirit Lake. Those are hummock type material. We've got Harry's Ridge, which was just blasted by Mount St. Helens. Here, this is 10 years or 30 years after the event, and yet we've got very little for trees on that blasted nose of Harry's Ridge. You got the Pumice Plane on the left here, where we've got a fair amount of growth and stuff happening on the Pumice Plane 30 years after the event. Some places were protected. We'd have a ridge and valleys here, and we see all the greenery starting here. This is just about not quite 2 months after Mount St. Helens blew. So some recovery happening there. Closer you are to the mountain, though, the less the recovery is because of the heat and stuff. This is by Mead Lake, and this is 1983. You can see the little trees, 3 foot, 2 foot high, 4 foot high, 6 foot high, 1980 to 83. If we look at 1989, now 9 years out, and some of these trees are 15 and more feet high, 18 feet high. Same site as this, just 6 years later. There's numbers of things that help bring about biological recovery, and the erosion crevices and stuff help protect from the wind, help soil blowing dust gather, so seeds got stuff to grow on. The fact that there's a big herd of elk, they were reproducing very fast once they came back in there, twins and triplets every year by a fair number of those elk. That's not common in the wild, but when you got a low population, it responds with higher reproductive rates a lot quicker. And their tracks and stuff, again, were gathering places for blowing soil and blowing seeds and stuff. Gopher mounds, we'll look at them too. And gophers bringing up soil from below the pumice and stuff. So there's 2004. That's 24 years after. Here we got 31 years after. More recovery. Here's the 1980 Pumice Plane. Nothing. More of the Pumice Plane. You can see the mountain in the background and Spirit Lake in the foreground here. Not much left there. This was one of the first plants that pussy paws that came into the pumice area. Depending upon who's doing the reporting and stuff, there was one lupine plant that actually came up through the pumice from what was growing there before. And so some people say that was the first plant. Well, that was one that had been there. This is a plant that had not been there that now came in. Other plants are coming in, and eventually we got trees coming into the Pumice Plane. And you can see Spirit Lake in the background here and Harry's Ridge and stuff. The erosion areas holding more water, letting dirt gather, and pretty quick you got things growing. 2021, that's 41 years after, and that Pumice Plane is now, this is the Pumice Plane that was nothing in 1980. Look at all the little trees and stuff coming on that. And one of the guys that was a big factor in that is the pocket gopher. He was hibernating in the winter. Come spring, all of a sudden now there's X amount of pumice above him. I don't know, 1, 2, 5 foot, whatever. He digs his way out, and he wants his tunnels enlarged down below. So he's bringing up original soil from down below, along with original seeds, putting those up on top, and now they can start growing. So he is one of the heroes. Some rock record was obviously formed in all of this, all those layers and stuff. And wherever you go in the world, the rock record is accurate. But how do we know what happened? And here we saw a lot of what happened right in the happening. And so we can interpret better in the future. When we see things, what really fits with reality. So let's start looking at some interpretation based on what we've learned from Mount St. Helens. Most of us have been taught that when you see layers, you see long time to lay all those layers down. However, about 75% of the Earth's surface is this laid down material. That's the top 2-3 miles or so of the Earth's crust. And down deeper, only 5% of those top 10 miles of the crust is laid down material. And this is flow material. There's no erosion, no plant life, no animal disturbance between these layers. All of this was laid down in hours and weeks, days and weeks, all in rapid order by water flow. Flow and layers go together. So we've got a catastrophe in order to move great amounts of material around and in short order and lay it out. So let's look at closer to home here. We've got the Twin Cities up in this part of the map. Down below, we've got the Iowa-Minnesota border, and we're going to look at a cross section of about 2,000 feet deep along that blue line. And here's what it looks like. Again, there's no erosion or animal disturbance between the layers. It was all laid down rapidly. However, as the flood recedes, more than 1,000 foot up in the Twin City area is eroded away. And this is what it ended up looking like, had been like we saw. This is what it looks like. And then we have about 4,450 years since then for all kinds of erosion and stuff. Now, instead of having nice layers in this last 4,400 years, if it was being laid down, it wouldn't be smooth like that, because this is how it's eroded over the last 4,400 years. And we're going to take a look also at more detail at the St. Peter sandstone here. Again, this is all the way from north of the Twin Cities. Well, look at here. This is how far the St. Peter sandstone is spread over the United States and southern Canada. 30 to 200 feet deep in places. And the worldwide flood changed what the surface of the earth looks like. And I think this was an actually larger area yet. And then as preceding mega sequences laid down different layers. The ones that followed eroded some of them away. And I think there's a fair amount of erosion that took place here. But it takes a worldwide flood to put down a 30 to 200 feet layer of sandstone over this size of area. You just can't do it in a local flood. There's a book called Carved in Stone. Dr. Clary spoke in August at TCCSA. You can look online and find that from the TCCSA website where he spoke. And he did about 2,000 strategic columns from across North America, South America, the Middle East, and parts of Europe. And some of them were like, this is a stone drill core from the lead mine in South Dakota. You can see the layers maybe and stuff in that. Comparing that to a larger one from South Carolina or North Carolina from in a mine. These cores were just some of the material that he used to learn a lot about the soil sediment layers worldwide. Nobody had done this kind of material before. And it's highly repeatable. It's real. It's not imagined dated, and it's not imagined interpretation. People can take and look at the same stuff and they'll come up with the same data. The geologic column, to me, didn't make a lot of sense before reading his book. And I'm going to spend a few minutes going over that because I think the global flood is going to make a lot more sense to you, and the geologic column also as a result. And I've got two different versions of the geologic column here. Here you can see like the Pennsylvania and the Mississippi and spread out like that, whereas the Carboniferous, so different names you might be able to relate to better as you go along. But there are mega sequences that all of this is based on. And a mega sequence is a combination of sandstone, shale, and limestone. Not always in that order, but those three things laid down. And then there's erosional boundaries. In other words, the ocean at this time was this deep, recedes and erodes some, builds up, erosion. It's based on erosion. And here's where the sea is at presently. But these mega sequences, anybody can, that's a geologist that wants to study these strategic columns, stratigraphic columns, and they're going to come up with the same kind of data that we're going to be looking at here. They use the outcrop data, oil well, boreholes, cross sections, seismic data, and it's not all done worldwide yet, but it's done North America, South America, Africa, the Middle East, and parts of Europe. And they're continuing to work on the rest of the world. But from that, we get phenomenal information. The Twin Cities in South is all southeast Minnesota. And this was laid down at this point well within the first 40 days of the flood. And here we see the St. Peter sandstone, St. Peter being the St. Peter River. We now call it the Minnesota River. And by Fort Snelling, where that joins with the Mississippi River, they called this the St. Peter sandstone because that's where they first described it. The Glenwood Shale is from a township name in northeastern Iowa, the Platteville limestone from the city of Platteville in southwest Wisconsin. But again, limestone, shale, and sandstone making up these sequences. And the order isn't always the same, but it's those three things that are. From his data, this is what the global world looked like prior to the flood and about the first 40 days of the flood. By day 40, these water areas, North America here has squished down and closed up these water areas and crunched into Europe and Africa. This is all based on observed data. It's not speculation. They've got the hard data now to show that. It's about day 40 before the thing that we call Pangaea shape is seen. And a psalm that I really like is 95. For the Lord our God is a great God, a great king, greater than all gods. He holds the depth of the earth in his hands. The mountain peaks too belong to him. The sea is his. He made it, and his hands shaped the dry land. So the geologic column we know now, and these sedimentary deposits that result from a worldwide global flood, is a record of the water levels during and following that flood. And they've got the hard data now to show that. Day 1, there's about 12 plates, major plates in the world forming. And during the first 40 days, we have these aspects of the geologic column. Somewhere in this area, we see the volcanoes increasing. Up in this area, they greatly increase. And we'll talk a little bit more about that right now. The ocean crust is 3.7 to 6.2 miles thick now. The blue here is the oldest crust in the ocean. And that all was formed within the first 50 days or so of the flood. And then between the 50th and the 100th day, we get all of this kinds of stuff forming, all the greens and some of the lighter reds and stuff. And then the last part of the flood and continuing on, we get the brighter red part. Again, there's 12 major parts. And we learned a lot from that small Mount St. Helens, but that's just one volcano. Look at all of the volcanoes around the world now, and they kind of follow the plate outline. Earthquakes also follow the plate outline. From 1960, so we got to 2008, 48 years worth of earthquakes that are shown here. And where you got the brighter, wider red ones, there's still subduction happening. The continents are moving anywhere from a half an inch up to 6 inches a year. So over 10 years, you might have some places moving as much as 5 feet yet today. In 2013, there was a deep earthquake. And from that, they learned that when these things split and move, the great fountains of the deep is where I'm going with this, thinking that these plates, when they broke up, this is moving along at about 2.5 miles a second in 2013, and maybe how fast it moved originally during the great fountains of the deep breakup, I don't know, but 2013, they know it moved at 2.5 miles a second. That's moving right along. We are into the latter part of the first 40 days before the earth crunches together that wet area, that inland sea area, and it starts to be Pangaea shaped. And so this is about day 40 when we get this kind of shape. And then over the next, by day 314, this is all this major movement is done. So we've got about 314 days for all of this runaway subduction to move these continents and stuff. Again, the runaway subduction of the 12 major plates really kicks off after about day 40. It's broken up, I think, the fountains of the deep at the beginning, and the first 40 days is moving, getting that inland sea crunched out of there, and then we're into the actual land moving after day 40. North America splits from Africa somewhere in that days 50 to 70. We're not sure exactly the dates. but that's close based on the strategic column, stratigraphic columns. South America splits from Africa about day 100 of the flood. And so we've got Pangaea, and we're going to look at day 40, the land areas based on the stratigraphic columns again. Northern Africa, some of it is covered with water, not very much Africa, whole lot even less of South America. North America, however, much of it was low sea area, and much of it is covered at day 40 already. Very few people probably in the world have been greatly affected by the amount of water at this point yet. Most of them they figure are alive yet at day 100. This right after day 40 is where these platelets really start moving fast, and we get the runaway subduction. The runaway subduction also pulls down the continental crust by about 1.8 miles. And that allows 1.8 miles. That's most of 9,000 feet or so, allows for another 9,000 feet of water on the surface of the earth. Just that part alone. But these volcanoes are making new lighter ocean floor that floats higher, and that causes the water to rise and cover the land area also. So we got two processes that cause the water to come in over the ocean or over the land area. Pangaea, those actual continents and stuff really start to split apart at this point. North America and Africa split. Here's day 100, about right that time's when South America and Africa split. Here we got day 150, and day 150 is the high level of water. From then on, we're going to have receding water and a lot of strata being laid down yet and stuff. But runaway subduction, the continents by day 314 are pretty much in place what we see today. Again, they're moving a little bit, but not much. Here's day 150, and again, that's finalized by about 314. Day 150, South America is still fairly close to Africa. Spain and Italy aren't in place yet. South America and North America got to join together with Central America. Just a lot of things happening yet here. This is day 150 based on the stratigraphic columns. And again, by day 314, we've got pretty much everything done. The burying of critters in the geologic column. And every time the water raises, there's a new amount of land that's covered now, and new animals, higher living land animals living at higher levels, and those get covered. But there's also tsunami-like waves happening and stuff that are bringing some of the pre-stuff in with the new stuff, and so you get a mix of all kinds of things together. But basically, the fossil record is what lived at what level that the water is at what day of the flood. And so the lower you are, the closer you are to the beginning of the flood, and the lower the water level in just the oceans, and then eventually onto the dry land, and then eventually all the land covered. Here we got day 40. There we got day 100. There we got day 150, and from then on it goes on down, and eventually we get into the single long ice age. This is not evolution or succession of life. Rather, it shows what was living at what level as that sediment from that level is being deposited. And this is the signature that says this is the worldwide flood, and here are the water levels that were happening during the worldwide flood. That's just a really neat understanding because of the strategic columns that Dr. Clary put together. And again, we got those water levels and stuff you can see with this, and you can study these in more detail on your own. During the receding floodwaters, major sand and coal deposits happening. The Whooper sand in the Gulf of Mexico, and they just rediscovered this in recent years. Probably a number of other places in the world have large sand deposits like the Whooper sand. The Ogallala Aquifer from South Dakota to Texas, that's where the water is stored for much of the Great Plains irrigation of our crops and stuff. And that's all laid down as the receding floodwaters leave. Coal deposits, again, are based on the flood. They're not very thick coal deposits in the east, and they're laid down between days 40 and days 100. And there's certain trees and stuff that are very, this is a fossil of root in one of those trees. This is another segment from one of those trees. And I don't know exactly what part that is, but I know it's from the east there. In the west, there were huge log mats and tree mats and vegetation mats floating. As the water recedes, some of them are buried, and that's why we get the 50 to 200 foot thick coal deposits. That's big amounts of common tree remnants, whereas in the east, it's small amounts early on. Here are the common coal trees from Kentucky, up to about 100 feet tall. The runoff pattern, I want to change here a little bit to as the last kind of concept. The runoff pattern in Wisconsin, if we look, there's much side branching. Here's a main river, all this side branching and stuff. That's runoff from the flood as far as I'm concerned. This is down by Camp Douglas. The Little Grand Canyon is more like a river or lake breach with very little side branching, except up close to Mount St. Helens, where the mud flow is spread out, more like a receding flooded area. But the further down you go, the more it becomes like a breach of a dam in a lake, and you get just a straight shot. And I've got great respect for Walt Brown, but I think when it comes to the Grand Canyon and Dr. Steve Austin, both feel that it was a lake breach that formed the river there. Might have been a lake, so to speak, in the whole flooded area that helped form that. But I think there's a lot of side branching that tells me there was a lot of water around the general area. When this whole area washes off, it's already, this is during the receding part, between day 150 and 300 and some. You can see that the material has already hardened a fair amount, and it's being eroded, and there's some parts left behind. And in the Grand Canyon too, there's a lot of limestone and stuff, ocean material mixed in, so you get the hardening in short order, short numbers of weeks, days, weeks, and months. It doesn't take hundreds of years to form hard layers that won't erode away. So that's my take on that. The Grand Canyon is 450 miles long. There's other Grand Canyons in the United States and Greenland, Antarctica. All of them were formed during the same basic receding of the flood time. And it requires global flood to make all of these Grand Canyons in the same time spread around the world. And if we look here a little closer, well, there's large amount of water retreating off of all sides of this whole area, and with the river cutting deeper. But as this water level is decreasing, it's uplifting, actually uplifting, and they figure about 5,000 feet down in this area. And here we can see all of these side canyons and stuff, gully headed and amphitheater type headed side canyons. Again, I think that it is a receding of the flood time that a lot of these side canyons and stuff are all being formed. And whether there was the break in the breach in a lake to kind of initiate it, that breach would have been below the spread out waters of the flood in general, and may have started the river, but somehow or the river that starts, and we get all this side branching and stuff. I think Dr. Walt Brown is the only one that's really come up with the asteroid solving where they come from. And you'll have to look at his own materials there, but there's a lot to be studied here. Julie Von Vet and several others from TCCSA joined us in August, and Julie and I were walking out together and got this picture. It was a grand 5 days out there at Mount St. Helens. Jesus answered them, "You are deceived because you don't know the scriptures or the power of God." And with that, any of you guys got questions?
Yeah, this is Alan. I'll ask you the first question. Just remind me again, Little Grand Canyon of Mount St. Helens versus the Grand Canyon, Arizona, about, what percentage of size would the Little Grand Canyon of Mount St. Helens be?
Well, the Little Grand Canyon is really small. They say about 1/40th the size of the Grand Canyon. We got 400 and some miles of Grand Canyon, and we got about 14 miles of Little Grand Canyon. We got over a mile deep of Grand Canyon, and we've got about 150, 140 feet deep of Little Grand Canyon. Obviously, they are canyons, and we, in real time, could see how canyons were formed in the Mount St. Helens area. And I think that's got a lot of application for us to help better interpret how the Grand Canyon itself was formed. Thank you for the question. Other questions?
Do you need a permit to climb up to the old summit of Mount St. Helens?
Yes, there are different permits available. Friends of mine have climbed up to the rim on Mount St. Helens, and then they slide down actually on the snow to get back down. So it's a long hike up and a short time down. And that's a fairly easy permit to get. It's just limited basically on the number of people that want to go up at any one time, or that are applying for the permit. However, where we were down in the Little Grand Canyon, there's some areas that the government is protecting in between. And I think it took Steve Austin 19 months to get our permit. And he's done research out there for lots of years, and he's well known by those people. And yet it took him 19 months to get a permit for us to be able to go down into the Little Grand Canyon. So that was really a special, unique opportunity.
Don, I have another question for you. People often ask why we can't find fossils of humans that were, pre-flood, came about during the flood, where you talked about there's probably 20 humans buried in Mount St. Helens, and yet those people can't be found. So, I mean, can you elaborate on that?
Okay, that's a really neat question and a good question. Yeah, we know there's 20 people buried there. And yeah, we have not they have not found any of those bodies yet due to erosion or whatever. Most of the people probably lived up through about day 130 or 40 of the flood. They could keep moving to higher land and higher land based on these stratigraphic columns. They figure 130, 140, something like that, where a lot of the people were eventually drowning. However, this is just near the deepest part of the water, and there's not much deposit happening after that. The water's receding. There isn't new stuff putting it on the high areas where the people were. And so in general, people didn't get buried very deep or very much, very common in the flood. I worked for the DNR and dragged for bodies of drowned victims and stuff over the years. And after a period of time, if they're not found, they're going to be floating. And those people aren't going to fossilize those bodies. So I think that's a lot of it. We don't have real deep sedimentation happening at the time the people are dying. Does that?
Yes, that's good. Yeah, I never thought of that.
And anybody else?
Are there any predictions about whether Mount St. Helens will erupt again?
Well, I will predict that Mount St. Helens sometime will erupt again. I don't know when. Since 1479, there's been 4 major eruption periods that they're aware of, and that's based on human recording. Prior to that, there are also several major eruptions of Mount St. Helens. And again, Mount St. Helens is probably becomes a volcano late in the receding of the flood, rather than in that day 40 to day 100 when most of the volcanoes of the world were formed. Somebody else?
Okay, well, I think you answered all of our questions and gave us a lot more to think about. So thank you very much, Don. Appreciate this very much. And this is going to be on YouTube and on Rumble.
I think it's a very important topic, and I hope I've caused you to see the power of God in a new way, and to want to study this further, so we get accurate interpretations of what the rock record really shows. Thank you.